To get ready for our first Algebra 2 test, I will be going through some of the steps, not all of the steps, but some of the steps, and you should be able to finish it up, each problem on your own. Here are the steps to question number 1. Negative exponent. Once we recognize it, we write it as a reciprocal, cross the line, and change the sign. Problem number 3, we notice we have a negative exponent, so I colored the top in yellow. Negative exponent, we put it on the bottom, and the exponent is positive. The bottom expression, binomial, has a negative exponent. I colored it in red, and I put it at the top. So now we have all positive exponents. We can do power to a power, and then we can simplify from there. So for number 4, I recognize I have a negative exponent. So here it is here, my negative exponent. So everything is attached to, I put it, highlighted it. So that's going to move to the bottom down here, and the exponent becomes positive. At the top, I'm going to leave 6 times negative 3c squared d to the 5th. And then I'm going to go ahead and put the exponent back on here, which is 3 is positive. So you'll do power to a power. And don't forget, negative 3 to the 3rd power is going to be 27. So you'll have 6 on the outside, 27 on the inside, c to the 6th, and d to the 15th. All of this on the inside. And on the bottom, when you square negative 4, negative times a negative is a positive. So you get 16c to the 8th, and you need to simplify from there. Number 5, we have a 0 as an exponent. Anything to the 0 power is 1. So my numerator is going to be 1. And in the denominator is 12 kp. Number 10, this is a fraction. Sometimes students get confused with this, but we're going to write it as a numerator and a denominator. And so 1 will be at the top, and guess what will be at the bottom? 10 will be at the bottom. Okay? We don't have any negative exponents, so everything else will be at the top. That'll be x to the 3rd, y to the 7th, all squared, times 6xy. So you would square x to the 3rd, y to the 7th. And then in the end, you would bring your x's and stuff together and do what you need to do to simplify this problem. For problem number 7, when I take a look at it, I notice that I have negative exponents here. And so I'll go ahead and get my line together so that I can have my numerator and my denominator. And so I go through who stays at the top, negative 3, a to the 3rd is at the top. Everything with a negative exponent moves. C to the 0 is just 1, so that goes away. 2a squared at the top, b to the 1st at the bottom, 6a at the top, and b to the 3rd at the bottom. And from there, you would simplify so that you only have a's, 1a in the problem, and 1b, and it can be to whatever power you get. Take a look at number 8. When I look at number 8, I have to pay attention that there is a subtraction sign in here. So what I'm going to do is I need to rewrite this. This will be negative 6p squared plus 3p plus 30. And what I do is I need to rewrite and distribute this negative throughout the parentheses. So this will be plus, okay, negative 9p squared minus 4p plus 10. Now go through and combine like terms. See what you get. For this one right here, 5x minus 2y to the 2nd power. Students forget you have to write this expression twice. Then you can use the box method or FOIL or the distributive property twice, but this is how you set these problems up. Problem number 10, we have a subtraction, so we're going to go through and distribute this. So when we distribute this, we're going to keep our 3x plus 4y, but now we're going to distribute, and we're going to get plus, and then this becomes what? Negative 8x, and what else? plus 20y. Go ahead and add like terms and see what you get. Okay, so for number 11, you can see that this is multiplication. There's no plus sign in between. There's no negative exponents. This is multiplication. So we're going to take 4a and multiply it times everything in my second set of parentheses. Okay, we're going to come back and take b and multiply it times everything in the second set of parentheses. So I have 4a times a squared, and 4a times a squared would give me 4a to the third power, and then 4a times 11ab will give me plus 44a squared b, and then 4a times negative 5b squared will give me negative 20ab squared. Now I would do the same thing with this b, and then whatever I get from that answer, I would add it to this for my final answer. Okay? All right. Hopefully that'll help get you started. Okay, for this next problem, take the time to see what you notice. I have a term on the outside, and it's being multiplied by everything on the inside. That's actually what we need to do. Okay, so we're going to take 2/3 x to the third y and multiply it times 6x squared. And when we do that, 2/3 of 6 is 4. So 2/3 of 6 would give me 12 over 3, which would equal 4. Okay, see, we'll be right here. Good. So then this is 4. I have x to the third, and x squared will give me x to the fifth, and we still have y. We'll do the next one. 2/3 of 9 will give me plus 6, and then I have x to the third and x to the fourth, which would give me x to the seventh. Y squared times y will give me y to the third, and then you could do the last one and write in what will go here. No like terms, so when you get that in, you'll be done. Okay, so as we start these, the directions say to factor, and let's just think about our little factoring graphic organizer. We're going to look for GCF, and then we're going to determine if it's 2 terms, 3 terms, or 4 terms. Okay, so we look for GCF here. Is there something that we can pull out of both? And yes, it is. What is it? 2x. So basically, you're dividing each term by that 2x, and so let's see what we have left. We have 9x squared minus 1. So the question is this 1 term, 2 terms, or 3 terms? And basically, depending on how many additional subtraction signs you see, will tell you how many terms, okay? So we see 1 subtraction sign, so that means we have 2 terms, okay? We have a term here and a term right here, so it's 2 terms. So is this a difference of squares, difference of cubes, okay? And so it's a difference of square. And so our final answer is going to be 2x. Always bring down your GCF or you're going to lose points. 3x minus 1 and 3x plus 1. That's the rule when it's difference of squares. Next problem, is there a GCF between the two? No, it's not. And it's a plus sign, so there's no sum of squares. So we want to know, is it a sum of cubes? Do we have a perfect cube? And we do. So we're going to break this down. This is 2a times 2a times 2a. And 27b to the 6 is going to be 3b squared times 3b squared times 3b squared. So we're going to put it in the model that we learned for factoring cubes. First set of parentheses is 2a plus 3b squared. Second set of parentheses, we need 2 of these, so that's going to be 4a squared. 1 subtraction, combination of these two, so 6ab squared. And then we need the last term to be 2 of these, and so that's going to be plus 9b to the fourth. Done, 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 done. Next one, 3 terms. Do we have a GCF? No. So if we don't have a GCF, this is going to go in factored form like this. Our first term, the factors are going to be 3 and 1, and the last is going to be 2 and 2, or 4 and 1 with an N on the back. Okay, so let's try 3M and M, and let's try 4N and 1N. Well, this will give me 4, and this will give me 3, and that'll be 7. So we got lucky, and we did it on the first try. Yay! So let's take a look at number 16. So number 16, when we look at it, GCF in 2 terms. Okay, so we pull out the GCF, and this is what we have left. So if it's 2 terms, we need difference of squares or difference of cubes. So we have difference of cubes. So we're going to write in 2x times 2x times 2x. And then 1 is 1 times 1 times 1. So let's go ahead and put it in our factored form. 2x minus 1. And then we need 2 of these. So 4x squared plus 2x plus 1. And don't forget, put your GCF in front or you lose points. Taking a look at number 17, there's a GCF here. So, and it's 3 terms. GCF in 3 terms. Pull out the GCF first. So we pull out our GCF of 2. And we have 3y squared minus 19y plus 4. So we have 3 terms. So go ahead and get ready, factored form. Look at the factors of 3, 3 and 1, and the factors of 4, 4 and 1, and 2 and 2. So for this one, we pull out the GCF. Again, we pulled out the GCF is 2, and we get ready to put it in factored form. We do 3y and y, and we do 4 and 1. And what we find out when we do this is that our loops, no matter what we try, 2 and 2 and 3 and 1, will not come out to a negative 19. So what does that mean? That means that this is as far as we can go with the factoring. Final answer is right there. All right, let's walk through this factoring one right here. There isn't a GCF, but it's 3 terms. So we're going to get ready for factored form. Our first term is x to the 4th, so that's going to be x squared and x squared. And our last term is 10, so that could be 10 and 1, or it could be 5 and 2. So we just got to check. So we're going to do x squared and x squared, and let's try 5 and 2. This loop gives me 5x, and this loop gives me 2x. Yay, it worked. However, we need a negative 7, so it'll make both of these negative, and there we go. We factored this. The question is, can we break this down any further? Always check, and the answer would be no. Okay, as we take a look at number 21, I look through and I pull out a GCF, and it is 2AB. I know it looks kind of weird, but we're going to go with our rules. We pulled out a GCF. We have 3 terms, and so since we have 3 terms, let's just get ready for factored form here. See if it works. Okay, in the front, I have a squared and b squared, so that will be ab and ab. In the back, I have 2, so that's going to be 2 and 1. So let me put a 2 here and a 1 here. See what I get? Loops, 2 and 1. That didn't work. So let's see if we can, anything else we can do with this. If we switch it around, it's not going to work. We did 2 and 1, 1 and 2. So how far can we go? Let's see. We tried, but this is as far as this one factors. So let's take a look at 22 and 23. All right, so for number 22, can I pull out a GCF? Because that's the first thing we think about. I can't. How many terms do I have? I have 4. Yay! So what we can do is we can group things together. If I group these two, I have something in common. But if I group these two, I don't. So, let me rearrange my groups. I am going to put 5x squared plus x cubed together. And then I'm going to put 125 plus 25x together. Okay, so that's my grouping. I can do that. So let me put some parentheses around my groups. 5x squared plus x to the third power. 125 plus 25 to the x. Well, we said in our note card that once we group, we try to find a GCF. So the GCF that I'm pulling out here is x squared. And what do I have left? 5 plus x. Over here, what do they have in common? 25. So I pull out 25, and then what do I have left? 5 plus x. We said in our note cards that once we do this, we're going to look for another GCF, which the GCF now, this has an x plus 5, and this has an x plus 5. So I go ahead and pull that out as a GCF. You could write 5 plus x or x plus 5. Pull out what's in green, and what is ever left, you put that in the other set of parentheses. X squared plus 25. Voila, that's it. Last one. Well, this one looks like it's almost done for us. Okay, we had the factor by grouping. Looks like they pulled out a GCF, but this is 2 minus y, and this is y minus 2. So what I need to do is I need these two to look alike. So what I'm going to do is I am going to make my x negative so that I can change the signs on everything in parentheses. So now my y would be positive, and my 2 would be negative, and I still have 5y minus 2. Notice that now I have a GCF right here, y minus 2 and y minus 2. So I'm going to go ahead and pull that out, GCF, which is y minus 2. And then I'm going to put what's left, which is negative x plus 5, or I could write it as y minus 2 and 5 minus x. Done. Good luck on the test.